All right, so in this section, we're going to look at simplifying radicals again, but we're not just going to have numerical radicands, so not just numbers under the root sign, but we're going to have variable expressions under there. Okay, so this is a little more complicated, so you got to have your algebra hats on when we go through this. So we're going to look first of all at expressions under the root sign that are simply a variable to some power, like x to the power of n, or sometimes we'll have a number times a variable to that power, ax to the power of n. But whichever way you dice it, we're restricted for this course. We're only allowed to look at, we're only going to look at stuff that is a square root, okay? So no cube roots, they're no good to us, nothing beyond that. So just square roots for this stuff, all right? So we're told in our magical documents that teachers are sworn to memorize. Just kidding. So first of all, we're going to simplify the square root of x to the power of n. So there's sort of two cases we have to look at this. What if we have the square root of x to an even power, like 4, 6, or 8? Or then again, what if we have x to an odd power, like 5, 7, 9, etc.? Okay. Well, the first thing you got to remember is that if I'm taking the square root of x to some power, let's say something simple like x squared. Well, what happens if I square something and then I square root it again right away? Those two operations just sort of undo each other. So for instance, I should just get x. As an example, if I have the square root of 3 squared, that's just going to be the square root. Well, 3 squared is 9, and the square root of 9 is 3. So it's kind of like the square and the square root kind of cancel each other out. Okay, so when n is an even number, that works out really nice. You can think of it as sort of the square root of x to the power 4 would be like x squared because it's x times x times x times x. And then you can get rid of the radical in the outside square, so you just sort of get x to the power of 2. Another way to say that is remember your exponent rules from grade 10. X to the power of 4 over 2 is another way to say that, and if I take 4 over 2, I just get x to the power of 2. Similarly, for any other even power, if I'm taking a square root like these, all I have to do is just divide the exponent by 2, and I get my answer. So that's pretty straightforward. So the process there is just take your exponent and divide it by 2. But when n is an odd power, you could still do that, but you get ugly decimals and stuff in your exponents, and it's not as nice. And we prefer to have nice whole numbers when we simplify things. So what we kind of do is we just sort of say, well, say x to the power 5 would be like x to the power 4 times x, if you remember, because x to the power 5 is 5x's all multiplied together. So let's just group 4 of them as x to the power 4 and leave one lone wolf out there. So that's going to give us the square root of x to the power 4 times the square root of x. And as we already saw, the square root of x to the power 4 is just x squared. So this becomes x squared root x. Okay, so in a similar way, x to the power 7 would be square root of x to the power 6 times x, which we could make x cubed root x. So basically all you're doing here is you're subtracting 1 from the exponent, dividing that by 2, and then multiplying by root x. So this one is going to become x to the power of 4 root x in that case. So that's how we sort of simplify those quickly when we have to deal with exponents that are both even or when they're odd. Okay, now what happens if I've got a number thrown in front of the variable or a coefficient that's also inside that radicand? We call that the a bit. Well, it's kind of sort of just putting two things together that you already know how to do. So let's take this as splitting it up. So we're going to take square root 18 times square root x to the power 4. We're going to simplify both of those things. So square root 18 we should know is square root of 9 times 2. And square root x to the power 4 we already know is x squared. So this is going to be, let's see, square root 9 is 3 root 2 times x squared. We just sort of throw all that back together. That's, we usually write the radical at the end. So 3x squared times root 2. Okay, let's do another example. Same kind of thing. So we split this up as root 75, which we should know how to simplify, and root x to the power 7, which we just saw how to simplify. So 75, let's see, that's the square root of 25 times 3, because 25 is a nice perfect square for us. And root x to the power 7, well, let's see, x to the power 7 should be square root of x to the power 6 times x. Okay, so if I'm going to simplify that then, I've got 3 root 5 over here. No, I don't. That's silliness. I've got 5 root 3 for that one. 5 5 root 3. And then on the other guy there, I've got x cubed root x. Oh, okay, so they're both simplified. So all I have to do now is throw it all back together, and I end up with 5x cubed times the square root of 3 times x when I put it all back together. So it's that putting it back together that you just got to be careful about. Okay, so let's see what happens if we try to simplify one that's already a mixed radical. So in this case, I've got junk out in front, and then I've got a square root of a pile of junk, and I sort of have to figure it all out when it simplifies. I'm just going to leave the stuff outside alone for now. Split up what's inside that radicand, so it's root 28 times root x to the power 5, like that. No big deal. So leave the 5x squared alone. Root 28, I guess that's root 4 times 7, because I know 4 is a perfect square. And then root x to the power 5, like we just saw, we'll call that root x to the power 4 times x. Okay, so we've still got 5x squared, and then this one becomes 2 root 7. Should be able to have it at that stuff by now. And then this one, the new part, is going to be x squared root x. And then we just sort of stick it all back together, keeping the sort of whole number bits together and the radicand bits together. So I've got to put a 5x squared, a 2, and an x squared together. It's going to make 10, and then x to the power 4 when I add those exponents, and then a square root of 7x. And that's how you do it, even when it's complicated. Break it down into smaller things that you already know. Okay, so when we're simplifying square root of x to the power of n, all we have to do is divide that exponent by 2, and we're off to the business. Off to the races, sorry. Or we're in business. But when x is an odd number, we have to tack that extra root x on after we subtract 1 and then divide by 2. Split it up, simplify, and put it back together if you've got that extra coefficient. We'll do some practice questions next time.